Hello friends, today I think in the last lecture we talked about how we can um, improve the performance of computer um, by using larger register file. Right? There are two approaches: the software based approach and hardware based approach. Uh, that was in the last lecture we have discussed this in very brief, but today I'm going to discuss it in details. Just give me a minute. See, when your computer is working, what happens is, let's just call this as your processors registers. Okay, so these are your processors registers. Okay, then this is your memory, and by memory I mean your RAM. Okay, this is your RAM. Okay, now when we are talking about a high level language, what happens there is there are many assignment statements. In the last lecture we have talked about what is the percentage of different kinds of instructions. I hope you remember that. See, and we also talked about uh, with respect to different languages. See, assignment statements 45%, in C language 38%. So these are the most of the statements. Okay, then 5% are loop statements, 15% are call statements. Just think about programming and what are the different types of operations. Okay, so if you want your program to be efficiently run, what we can do is, there is a software based approach and there is a hardware based approach. So in software based approach, what we do is, the computer saves the operators which are used frequently. These operators will be stored in processors registers. Okay, and then only when it gets the final result, that result will be saved to your memory, this memory. Okay, so that this time to fetch from your memory into your register, that time gets decreased, that time is saved, and this is how we can speed up the whole process. Okay, but what we need is to identify um, which operators are going to be used frequently in your program. That needs to be identified. Okay, for that you have to follow this analytical approach, which operands are going to be used frequently and which operands are going to be used less frequently, that you have to identify, and only the frequently used operators will be stored in your processors registers. As there are limited processor registers, we have to use these registers wisely. Okay, so this is called as software based approach because we are identifying which are frequently used operators and which are less frequently used operators. Okay, and now when we are talking about hardware based approach, what we are going to do is we are just going to simply increase this size, the number of registers. Okay, if we increase this, you can save more operators in processor registers itself. Okay, so here we are not identifying which are frequently used operators and which are less frequent operators. Okay, it is just the opposite. We are just going to increase the number of registers in your processor. And this can also improve the performance by speeding up the whole process because you don't have to again fetch the operators from operands from your memory into your process. Okay, I hope these approaches are clear, both approaches, software based approach and hardware based approach. Now let's go to our next point. Next point is register windows. See, uh, this is for what we can see procedure calls. These register windows are basically used for procedure calls, and there are different levels for procedure calls. Uh, Please try to remember what happens when you call a procedure. What happens is the control goes to that specified procedure. It executes the instructions given in that procedure. By procedure, I'm talking about a function. Okay, I hope you have studied functions in your C language. A function is a set of instructions which is used to perform a certain specified task, right? Then for performing that, for executing that function, what we need to do is we need to call that function. Okay, and that function I'm calling it as here procedure. Okay, if you want to execute that procedure, you have to give that procedure a call. When that procedure is called, uh, those instructions will get executed. So when uh, we are talking about procedures, what we can do is we can assign different sets of registers for different procedures. Okay, so this will be one set of registers, this will be another set of registers. These sets will be assigned to a particular procedure. Please try to understand. For every procedure, we are assigning a set of register, and that set we are going to consider that as processor's registers for that particular time. When that procedure is completed, we are going to use another set of registers which is used for different procedure. Okay, uh, let me try to explain here again. See here, let's consider this as one set of registers. So this will be one window. Okay, this will be one window for one uh, this will be one window of registers for one procedure. Okay, now let's take another window for another procedure. So let's just assume that this is for procedure A. Now let's assume that this is for procedure B. This is another set of registers which will be used for only procedure B. So this is another set of registers. So when procedure B is called, this will be active. This set of registers will be active. Okay. Now if let's say we again have a um, different procedure, then again different set of registers for that particular procedure. So this is for procedure A, this is for procedure B, this is for procedure C. B. So at one point of time, at any point of time, any one will be active. Okay, and that which one is active, which one window is active, that depends upon which procedure is called. Now, see, I have drawn these separately, but what actually happens in your procedure, in your registers is there is an overlap, so that you don't have to actually pass the parameters from one level to another level. They are already there. See, the temporary registers at level J is same as parameter registers at level J plus 1. Okay, so this is an overlap. This is window at level J, and this is one window at level J plus 1. These are basically same. This is the overlap. But these are totally different. These local registers and parameter registers at level J are different from local registers and temporary registers at level J plus 1. We can also call them as disjoint. These are disjoint, but this is common. This is the same. Okay, and at each level there will be an overlap. So how we can um, optimize this is, there is one more way. We can use a circular buffer. Okay, see, uh, let's see, say that it starts from here: a parameter, a local parameter, and a dot local registers. Okay, a parameter registers, a local register. This is window, and a temporary registers, B parameter registers. See, this is the overlap. Then again these local uh, registers and these temporary registers is equal to C's parameter registers. See, so these are the different windows for different procedures. Procedure A, procedure B, procedure C, procedure D, E, F. Okay, so it is uh, the window is in circular buffer. Okay, and this is these are the overlaps. Now, what how we can know which window is currently going on? So there are two different pointers. One pointer is saved window pointer, and another pointer is current window pointer. Okay. Now, um, at the start of your program execution, this current window pointer will be equal to saved window pointer. Okay. Now, then you are going to call procedure A, then procedure B, procedure C, procedure D. Okay. Now, what if a procedure D calls procedure E? Okay, this overlap will be used this time. Okay, and here you can see this is window 0, this is window 1, this is 2, this is 3, and this is the fourth window, and this is the fifth window. Okay, now the current window pointer is here, so our window is window number 4. Now, um, see, this is the D's temporary registers and E's parameter registers, right? So if when procedure D calls procedure E, this part will be used. Now, if procedure E again calls procedure F, procedure F's window is see here, window 5, and it overlaps this age parameter registers. Okay, so F's temporary registers is equal to age parameter register. Now there is this overlap. You cannot, the computer cannot complete this procedure F, because this is already occupied. This window is already occupied. This part is already occupied by procedure A's uh, uh, parameters. Okay, so what we have to do is we have to save this status, the status of A here. Then we can move this saved window pointer here, and this will be your current window pointer here. And then after saving this status of registers A, you can proceed for uh, execution of procedure F. Okay, this is a little bit complicated, but not that difficult. Please try to understand. This is how your procedure calls work by using circular buffer. Okay, this is a circular buffer of overlapped windows, and these are different windows for different procedures. Okay, we'll stop here for today, and we'll discuss our next point in our next lecture. Thank you.